Hello, grade 12 students. Today our lesson will be about the nuclear physics, chapter 30. We will start with lesson 30.1, which is about the nucleus. First of all, we have any element. Its symbol is X, let's say. You know from before that we have up A and down we have Z. So A is called the mass number or the atomic mass number. Z is called the atomic number. The atomic number, or it is the number of protons inside the nucleus. So we are talking about the nucleus. So this is the nucleus. It has protons and it has neutrons. So the number of protons in a nucleus is called the atomic number. Its symbol is Z, the small number next to the symbol of the element. The mass number A, it is the bigger number. It's called, it is the number of protons plus neutrons. Protons and neutrons together are called nucleons. So A is the mass number or the number of nucleons. Let's take a simple example. We have carbon 12. Let's take an isotope of carbon. Later I'm going to talk about isotopes. Later carbon 14, 6. So what is the number of protons? It's simply the small number Z here. So this is Z and this is A. So we have 6 protons. Proton is symboled as P+. We have how many neutrons? And how many nucleons? So we have, to find the number of neutrons, we just subtract N equal A minus Z, the big minus the small. So we have 14 minus 6, we have 8 neutrons. Neutrons are charged 0, neutral. And how many nucleons? Nucleons is together, neutrons and the protons are 14 nucleons. So this is simply what goes on inside the nucleus of an atom. We are not interested in this lesson in the electrons. We are interested only in the nucleus since it is nuclear physics. So, atomic mass unit before going to atomic mass units, let's define isotopes. Isotopes are atoms of the same element. When we say same element, we mean same number of protons, same element, same Z, which is number of protons. Different number of neutrons. they have more or less neutrons or nucleons. The total number inside the nucleus would be different. Example on this, let's go back to carbon. Carbon 12, 6, carbon 13, 6, carbon 6, 14. As you see, all carbons here have the same number of protons, different number of nucleons. And if we want to be more specific, they have different number of neutrons. Here we have 6 neutrons, we subtract up and down. Here we have 7 neutrons, and here we have 8 neutrons. And all of them, they have 6 protons. These are called nuclides. So when we have an element with isotopes, we say these 3 are the nuclides of carbon. We don't say atoms or elements of carbon. So isotopes, different isotopes of the same element are called nuclides. Now we have a simple definition, which is the strong nuclear force. We have many types of forces, as you know. We have the gravitational force, we have the magnetic force, electric force, but there is a special force, the force that holds nucleons together. This is the nucleus. Let's say this is the nucleus. We have a neutron here, we have a proton here, and let's say we have also a neutron here, and we have a proton here. As we know that the nucleus is very dense, and it is tightly bonded. The protons and the neutrons are tightly bonded together. They are very close together. How can this happen? And we have a plus with plus here. As we know, if we have plus and a plus, they should repel. But this is not the case in the nucleus. They are very strongly attracted to each other by a force called strong. It's called strong with capital S. It's a name, strong force. That's its name. It's the strong force. It's much, much larger than so this is the strong force in the nucleus. It's a force in the nucleus that causes its component to bind together and they have positive charge, and this strong force is much greater than the electric force of repulsion between them. Let's take an example about here we have number 2 in the book, number 2, page 804. We have Hg 80, 200. How many neutrons? We just subtract up minus down, so we have 120 neutrons. If we are asked about the number of protons, we have 80 protons, and we have 200 nucleons in total. So this is our lesson. We are not going to go through the binding energy and the calculations at the end of this lesson. We are going just to take these definitions and see you in the next lesson. Thank you for listening.